Water, a basic element of life and one of the most precious resources on this earth. Where water is plentiful, life prospers, crops flourish, and cities and industries are built. As our global population grows, the demand on our water supply increases. To meet this increasing demand for additional water, various methods are used to harvest water reserves, including vertical wells, infiltration galleries, surface water intakes, and Ranney collector wells. These methods are employed by experts after a comprehensive evaluation of the situation has been completed. Engineers evaluate the needs of the customer, appraise the site conditions, and present the most viable options for supplying the amount and quality of water needed. Ranney Collector Wells is a Lane Christensen company and has been involved in the construction of water supply projects worldwide since 1933. Ranney has both experience and expertise in all forms of water acquisition. Many underground sand and gravel formations adjacent to rivers and lakes are water-bearing and are called aquifers. These aquifers are very permeable and permit free flow of water into the aquifer through natural infiltration or recharge. Many times, Ranney collector wells are used to develop groundwater supplies from these permeable sand and gravel deposits. These special wells are constructed with a reinforced concrete caisson that serves as a wet well pumping station. Lateral well screens are installed near the bottom of the aquifer, resulting in high yields. Capacities can range from 1/2 million gallons per day to 50 million gallons per day from a single well. Let's hear from someone who operates a Ranney collector well.
I'm John Simpson, General Manager of Leax Water District. Our Ranney well has pumped over 6 billion gallons of water since being installed 10 years ago. Our 680 miles of pipelines here in southeast Ohio reach nearly 7,000 customers. We pump on average 1.5 million gallons per day and have pumped as high as 2.1 million gallons per day.
Now let's take a look at the actual construction of a Ranney collector well. After a potential site is selected, Ranney geologists conduct a complete hydrogeological investigation. Samples of aquifer materials are obtained. These samples are taken within a controlled pattern throughout the site to determine the makeup and size of the groundwater aquifer. The boring samples are collected in clear plastic sleeves and placed in sequential depth order on the ground. The hydrogeologist opens and examines each sleeve where depth and aquifer characteristics are recorded. Selected samples are sieved to determine optimum well screen design. This evaluation creates a clear picture of the underground sand and gravels, and most importantly, determines how deep the well will have to be. After careful evaluation of the boring samples, a test pumping well and a series of properly spaced observation wells are drilled. By pumping the test well, Ranney can observe the effects on the water table at each of the observation wells. Results of the test will be analyzed to determine aquifer coefficients, or the ability of the aquifer to transmit water, as well as allow for projections of the collector well yield and water quality. When the location of the well has been finalized, site preparation begins. A leveling course of concrete is poured. A steel cutting shoe is constructed on the first section of concrete caisson to assist in the sinking process. Here we see the completed cutting shoe. The concrete walls are reinforced with steel rebars, which are woven and tied before the concrete is poured. This procedure will be completed on each successive section of caisson. Next, the workers install concrete around the outside of the caisson to form a dead man, which will aid in the sinking of the caisson using the weight-assisted caisson sinking method. As the workmen continue to tie steel rebar, note that we see port assemblies already installed in this section of caisson. These port assemblies are the locations where the horizontal laterals will be projected through the caisson and into the surrounding aquifer. The outer form is positioned and the concrete is poured. This well has a 13-foot inside diameter. When conditions occur where larger yields are required, the diameter of the well will increase to accommodate larger pumps and motors. Ranney workmen constantly check the temperature and consistency of the concrete to ensure correct mix and curing time. It's now time to begin sinking the well. In a simultaneous twofold process, material is removed from the inside of the well with a digging bucket while constant pressure is added to the top of the caisson. This synchronized hydraulic pull-down system provides uniform, even pressure which ensures proper caisson alignment and aids in the sinking process. Construction continues in this manner until the top of each section of caisson reaches ground level. At that time, the next section of caisson is constructed and the process continues. When all sections of the caisson are sunk to the required well depth, a concrete well plug or seal is placed in the bottom. If the hydrostatic head is great, the plug will be reinforced with steel beams. Shown here, professional divers are assisting in the inspection of the bottom prior to the concrete and beam placement. A special pipe called a tremie pipe is positioned in the center and lowered into the well. A funnel is placed atop the pipe where concrete is poured through the pipe and into the bottom of the well to create the plug or bottom seal. As the plug is poured, workmen strategically positioned on top of the well takes depth measurements to ensure that the plug is of proper thickness. After the plug has been installed and cured, the water in the well is pumped out. Workers are lowered and raised into the well within the safety of a steel man cage. The next construction step is the installation of the horizontal lateral screens. But what are horizontal laterals? Quite simply, they're water collecting arms that stretch out into the sand and gravel aquifer. As shown here, horizontal laterals greatly increase the efficiency of the well's output of water as they extend into the water-bearing aquifer in all horizontal directions. Horizontal laterals can be up to 300 feet in length or longer. Let's take a look at the construction of the horizontal laterals. A digging head is placed onto the first section of projection pipe. This pipe with digging head is positioned for projection through a port assembly. Hydraulic jacks are used to push the pipe through the port and into the surrounding sand and gravel aquifer. Additional lengths of pipe are added and projected through the port and into the aquifer until the predetermined length is achieved. Shown here, a section of the projection pipe is safely lowered into the work area below and positioned for insertion into the lateral port using a specially designed pipe rack system. A smaller line, called a sand line, is contained within the projection pipe. This line is connected to the digging head and used to carry sand and gravel into the caisson, where it is collected and evaluated for proper screen slot size selection. Once the projection pipe is in the proper position, the sand line is removed and the workmen begin the process of well screen installation. Screen pipe is placed one section at a time into the projection pipe. Each consecutive section of screen pipe is secured to the one already in place. The process of adding screen pipe continues until the predetermined length is reached. Once all sections of the screen pipe are in place, workmen begin removing the projection pipe to expose the screen to the aquifer deposits. Pipe sections are moved safely to the surface from the work area using the pipe rack system. In a process called developing the screen, the sand line is reinserted into the lateral screen. Hydrostatic pressure forces water and sand and smaller gravel through the screen pipe and into the caisson. This process flushes the lateral of sediment. High-pressure water jetting is also utilized in the screen development process and is shown by the blue pressure hose. This jetting agitates the smaller sands and gravels around the screen and flushes the lateral of sediment. It is important to note that the development of the screen will vary depending on different geologic site conditions. Oftentimes, the geologist will choose to use Bore Blast 2 technology. This technology uses high-pressure inert nitrogen gas to create a pressure pulse causing acoustical waves to agitate tightly packed sand and gravel formations. As we see here, workmen are checking water flow for sand content. Once the sand content is reduced to the desired level, the horizontal lateral is temporarily closed. In order to better understand the hydrostatic process, let's take a look at a graphic representation of the activity inside the aquifer and around the laterals. Hydrostatic pressure forces water, sand, and smaller gravel through the digging head of the projection pipe and into the sand line. As this continues, larger, coarser gravel is repositioned against the projection pipe, forming a natural yet permeable full-length gravel pack around the pipe. Once final lateral length is achieved, the sand line is removed and the screen is installed. The projection pipe is then removed to expose the screen, and the sand line is reinstalled to remove any remaining fine sand during the screen development process. When completed, the sand line is removed, allowing water to flow freely into the caisson. Then, a pumping test is performed to confirm projections of well yield and drawdown. The final step involves the construction of a pump house, necessary pumping equipment, and water transmission lines. Once this construction is completed, water valves are opened and the well is ready for operation. The result is a complete pumping system contained in a single unit. Let's hear from another of Ranney's many satisfied customers.
My name is Frank Devo. I'm the general manager of the Southwestern Ohio Water Company. We have two large Ranney collector wells which have operated continuously ever since the early 1950s, with the exception of only periodic maintenance. These wells produce approximately 20 million gallons of water per day and supply our large industrial customers here in the Cincinnati, Ohio area.
One of the unique features of the Southwestern Ohio Water Company's system is that raw water is pumped to a reservoir where it can be distributed by gravity to its industrial customers and treated for their specific individual needs. This reservoir also provides storage for emergency backup. In addition, the Southwestern Ohio Water Company has incorporated an on-site emergency system for its customers.
We also have an additional Ranney collector with an alternate diesel engine drive, which can be used during periods of electrical power outages. We also have two auxiliary vertical wells. This is our main pump station, Ranney Well Number 1. It has 6 vertical turbine pumps with capacities ranging from 3,000 to 8,000 gallons per minute. These pumps are powered by synchronous motors ranging in size from 400 to 1,200 horsepower. This combination of sizes provides maximum operating flexibility. Water pumping rates, pressures, and levels, as well as electric motor information, are monitored and recorded on a continuing basis. Ranney collectors have served our company very well for almost 60 years, and we expect that they will continue to do so in the future.
Ranney Collector Wells is a Lane Christensen company and provides a full range of services for water supply development and treatment, including Ranney Collector Wells, vertical or slant angle wells, riverbank filtration systems, infiltration galleries, surface water intakes, hydrogeological investigations, water resource management, well field and wellhead protection, aquifer recharge wells, and complete design, build, turnkey construction and water treatment systems. Recent activities include seawater collector wells, typically installed along beaches and coastal areas where naturally filtered seawater is collected and used in the desalinization process or used directly for saltwater aquariums, as is our well at the famous Steinhardt Aquarium in Golden Gate Park. Ranney Collector Wells is proud to provide environmentally safe solutions to meet the world's demand for water supply development. Contact Ranney Collector Wells today for a confidential review of your specific water supply needs.